Okay, we're going to look at finding x-intercepts of quadratics in vertex form, and this is our vertex form, which is normally written as f at x is equal to our a. X minus h deals with horizontal translations, and plus k, which deals with vertical translation. Okay. And one method we could use to go to this is we could take it to standard form. Okay. And the standard form, we'll write it out as f at x is equal to a x squared plus b x plus c. Okay. And in order to do that, we expand. Okay. And then from the standard form, we can factor and take it to factored form. And factored form, or use the quadratic formula, will help us find x-intercepts. So let's say factor or quadratic formula. And maybe since we're trying to find x-intercepts instead of building the factored form, maybe we'll use the quadratic formula to get there a little quicker. Okay. So first thing we need to do is expand. So we'll expand our f at x is equal to 2x minus 3 squared minus 5. So sometimes in vertex form, when we're expanding, it's hard to tell when we can stop. So I'll kind of keep that as a general idea as we go. When we have a base squared, it's essentially the base times itself. So x minus 3 times x minus 3 minus 5. We then use FOIL. Okay. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Okay, and then minus 5. Now, before we can kind of drop these brackets, we have to distribute again. Okay, and I'm showing you distributing the four things, but really what I should do is simplify first. So I'm actually going to simplify. These two terms are like terms, so they can become negative 6x. And this way we only have to distribute to 3 terms. We could have done it to all 4, but this is faster. This is faster because now there's only 3 and the bracket is simplified as far as possible. So now we'll distribute that 2. And when you distribute the 2, we'll get 2x squared. 2 times negative 6 is negative 12x. And 2 times 9 is 18. And now the brackets are gone, so we can subtract our number 5. Okay. This could look like standard form, but again, I can simplify. I can simplify the last 2 terms. They are like terms. So the goal is just try to simplify as far as you possibly can. 2x squared minus 12x and plus 13. And the reason I know that none of these are able to be simplified is because this is x to the power of 2, this is x to the power of 1, and this has no variable. You could call it x to the power of 0 if you really wanted, but because none of the exponents on our variables are the same, we can't simplify. And the reason I can call that x to the power of 0 is because anything to the power of 0 is 1, and 1 times 13 is still 13. So it still checks out, right? Okay, from here we can factor, or we'll use the quadratic formula, because the quadratic formula says x is equal. So in other words, solving for x-intercept, negative b plus or minus the root of b squared minus 4ac divided by 2a. So first we have to figure out what our a value are. A value in standard form is the first coefficient we want to attach to our x squared. So we'll replace these a's with that value. The b is the second coefficient attached to the x, so we'll replace both of these b's with that value, and the c is the constant term, and we'll replace that c with that value. So with that being said, we get x is equal to negative 12. Okay, so that's going to be important because that's going to switch that sign with the square root of negative 12 squared minus 4 times 2 times 13. Let's get a calculator out there. Do you have one with you? Just so we can kind of move through this a little quicker. And 2 times the value of 2. Okay? Okay. So the underneath the bracket is kind of going to be the first thing. We have x is equal to, this will become positive 12. So plus or minus, this will be 144. So 144 minus 2 times 13 is 26 times 4 104?
Yep.
104. So minus 104. And all of that will be above the number 4. So these here, 144 minus 104 is 40. So what is the root of 40?
30? Oh, sorry, not 30. Is it 20?
You're thinking of times 2. But remember, we're looking 2 numbers that multiply to 40. So it's actually going to be 6 something, 6.3. We could say 3.2. It won't be as accurate, but easier for us to remember stuff. So we'll say 6.32, okay? So plus or minus 6.32. So we get 2 answers. That's what that plus or minus is telling us, divided by 4. So here's where we can kind of split. Okay, we'll split our equation. We get x is equal to 12 plus 6.32 divided by 4, and x is equal to 12 minus 6.32 divided by 4. This will become x is equal to 18.32 over 4. And you'll get you use your calculator to figure that out. And this will be x is equal to 5.68 divided by 4. What does this end up being?
4.58.
4.58, okay. And
1.42.
1.42. Amazing. So those are our x-intercepts. And if we look at our graphing calculator, that's it. 4.58, yeah, and 1.419, which is 42. And let's say, just to add to it, I want to put it in factored form. Equal to our a x minus r, x minus s, okay? And these x-intercepts are essentially our r and our s. How would I write my factored form of this? Let's say we don't know what the a is. What do I do with the brackets?
X minus 4.58.
Yeah, 4.58.
And then x minus 1.42.
Minus 1.4. Perfect. So we just plug those directly in. And how do we find the a value? Remember? Go back up. Because a is the same in all 3 of these, okay, see how a was 2 here, a was 2 here, a is 2 here. So I'm going to erase this a. I'm going to put the number 2. So we'll test this out. We'll go over here and we get 2 x minus, we said 1.42 and x minus 4.58. 4.58, and look at that, we got exactly the same thing. Now, technically, when I zoom in really, really close, I probably have to go much closer because we rounded. Let's see if we can catch it. There it is.
Oh,
You're starting to see they're not exact, but you have to be, and look at the scale we're at. We're at a really small scale. You can see it's a little different, and that's because we rounded. That our blue one isn't exact with our red one, okay? And that's due to our rounding. But for our intensive purposes, this is very, very, very close, okay?